Good day, viewers. This is Afia Demola Johnson, your science tutor. We want to start a new series in chemistry today, which begins with electronic configuration of elements. Electronic in chemistry. We want to start with electronic configuration of elements. Electronic configuration of elements. Some examination body like WAEC, we call it electron configuration. Configuration means arrangement. Then the word electron, what arrangement are we talking about? Arrangement of electrons. Where can we find electrons? In the atom. And atoms are present in certain molecule of elements. So this is the arrangement of electrons in the atom of elements. Now, electrons are arranged in the following two parts. Of an atom. Only two parts. There are only two parts where you can find electrons. First one is atomic shell. Atomic shell around the nucleus. Around the nucleus. Then number two, we have atomic orbiter. Atomic orbiters. So let's talk about atomic shell. So an atomic shell is a spherical orbit around the nucleus, around the atomic nucleus, where electrons are found revolving around the atomic nucleus. So electrons are found moving around the atomic nucleus in the what? Atomic shell. Basically, there are four basic types of orbiters of an atomic shell. We have number one is K shell, number two is L shell, number three is M shell, and number four is N shell. Now, we want to look at a table that summarizes some of the properties, types of shell. Then we have value of N. Then we have maximum number of electron held. Now, first one is K shell. Being number one, this N, later when we get to, we are also going to talk about quantum number. Then we will talk about what N means. It means principal quantum number. So we'll talk about it later. Then, but being number one, the N is 1. And the formula for calculating the maximum number of electron that an shell carries is 2n squared. That's the formula, 2n squared. So if you put 1, if your N is 1, so in the formula you already have 2 times N is 1 raised to the power what? 2. 2 is already in the formula. So this is a 2 times, this one is 1 times 1. So that is a 2. So K shell can carry maximum of 2 electrons. Then number 2 is L shell. Principal quantum number for L shell is 2. So because you have 2, put 2 inside this formula. You have 2 already here. Times, instead of n, put what? 2. But the 2 is raised to power what? 2. So this one is the same thing as what? 2 times, this one is the same thing as 2 times 2. So answer is 8. So L shell can carry maximum of 8 electrons. Then number 3 is M shell. M shell. So principal quantum number is 3. So put 3 inside here, you have 2 times 3 raised to power 2, which is same thing as 2 times 3 times 3. So that's 2 times 3 is 6. 6 times 3. This is 3 times 3 9. So we have 9 times 2. 2 times 9 is what? Is 18. So that is that. So M shell can carry the maximum of 18 electrons. And lastly, we have N shell. N shell principal quantum number is 4. So you have 2 times 4 raised to power 2. So this one is said as 2 times 4 times 4. So this one is given on 2 times 4 times 4 is 16. So that gives us what? 32. So this N shell can carry the maximum of what? Of 18 electrons. Now, let's now go and look at electronic configuration. Electronic configuration of the first 30 elements. Now, electronic configuration of the first 30 elements. We are starting with hydrogen. So, I hope you can recite the first 30 elements offhand. Please, you need to do that. So, we are starting with serial number, elements, and the symbol. Then we have electronic configuration. So first element we're talking about here is hydrogen. Hydrogen H is number 1. So the rule is that we are going to have K shell, L shell, M shell, and N shell. Now, in this one, we have learned that K shell cannot carry more than 2 electrons. But as a rule, Habermas principle, this is like a vehicle. This front seat of this vehicle must be fully filled with the 2 electrons. If it now remains, then you come here. So hydrogen has only 1 electron, being number 1, and that 1 electron can occupy K shell. Although K shell can carry maximum of 2, but it's 1 that is available. So next one is helium. Helium He. Now this one has 2 electrons, and K shell can carry maximum of what? 2 electrons. So we put the 2 here under K shell. Then number 3 is what? Lithium. Lithium Li. This one has 3 electrons. If you have 3, 1, 2, 3. Now the rule says put 2 inside K, then you are left with 1. So that's 2:1. So you have 2:1. So 2 is in K shell, while 1 is in what? N shell. So let's come back here. Now, number 4. Number 4 is beryllium. Beryllium Be. Now, then the configuration now, don't forget we have K, L, M, and N. Beryllium has 4 electrons. 1, 2, 3, 4. Take 2 inside K. The remaining 2 put inside what? L. Configuration is 2 to what? To 1. To 2. You have it there. So then the next one, which is number 5, is boron. Boron B. So boron has 5 electrons. Out of the 5, these 2 must come here, then the remaining 3 will come here. The next one is carbon. Carbon C. So has 6 electrons. 2 will stay here, 4 will stay here. The next one is nitrogen. Nitrogen N has 7 electrons. 2 will stay here, then 5 will stay here. The next one is oxygen. Oxygen O has 8 electrons. 2 will stay here, then 6 will come here. The next one is fluorine. Fluorine F has 9 electrons. 2 will stay here, 7 will stay here. Then number 10 is neon. Neon Ne has 10 electrons. 2 will stay here, 8 will stay here. Don't forget that we have said something, that the maximum number of electrons that L shell can carry is what? Is 8. So any other one now that will have more than will be going to M shell, we can carry 18 electrons. So we have, next one is 11, that's sodium. Sodium Na, 11. 2 comes here, 8 comes here, 8 plus 2, that's 10. So the remaining one will come to what? M shell. So we have it that. Then the next one is magnesium. Magnesium Mg. So this one is having 12 electrons. 2 will stay here, 8 will stay here, the remaining 2 will come and stay here. The next one is what? Aluminium. Aluminium Al. Now this one has 13 electrons. 2 will stay here, 8 will stay here. So this is 8 plus 2, that's what? 10. It remains 3 to make 13. So that remaining 3 will stay here. Here I can carry 18. So 3 can stay where 18 can stay. So number 14 is what? Silicon. Silicon Si has 14 electrons. We have 2 to 8 to 4. Now we come back to this place. We come back here. Okay. Now number 15. So we have K, L, M, and N. Number 15 is phosphorus. Phosphorus. Phosphorus P. So having 15 electrons, 2 stays here, 8 stays here, making 10. So the remaining 5 stays here. So then next one is 16. Sulfur. Sulfur S has 16 electrons. 2 stays in K, 8 stays in L, 6 stays in M. Then the next one is chlorine. Chlorine Cl. Now 2 stays here, then 8 stays here, making 10. The remaining 7 stays here. Then number 18 is argon. Argon Ar. Then having 18 electrons, 2 stays here, 8 stays here, then another 8, so that 8 plus 8 is 16, plus 2, that's 18. Then the next one is potassium, 19. Potassium. Potassium K. So this one has 19 electrons. For potassium and calcium, 20 calcium. Please take note of this. For potassium and calcium, you need to know something that is very important among the first 20 elements. And when we get to the transitional elements, we talk about copper and chromium. They have some exceptional ability. Now, for potassium and calcium, Ca. Now, for potassium, having 19 electrons, 2 stays here. Now, 8 stays here. Now, don't forget, this plate can take 18. So we're supposed to say, okay, what remains? This is 10 already. I'm supposed to have, this is 10, then I'm supposed to put 9 here. But no. For potassium and calcium, the M shell can carry 80 electrons. But the 3d orbital that will carry 10 out of the 80 electrons does not carry electron. When we get to orbitals, atomic orbital, will explain more. So they still behave like what? L shell carrying maximum of 8. So we put what? 8 here. So then put 1 here. So then calcium, Ca, the same thing. You have 2 here, 8 to 8 to 2. So if you have any question, you can put in the comment section. Let me hear you. Let me give you better explanation. 21 now is scandium. Scandium Sc. Scandium Sc. From 21 to 30, They are called transition elements. If you look at from 1 to 20, the difference between upper element and the next one is at the outermost shell. This one has 2 at the outermost shell, 3, 4, 5, 6, 7, 8, like that. So the increment is always at the back. But when it comes to from scandium to zinc, no. All the end shell carries 2, 2, 2, except copper and chromium that carries 1. So the increment is at end shell. That is their style. Now what am I talking about? You have 2 to 8. Here now, let me omit this space. They end in 2. Then the remaining thing is put here. This is 2 plus 8, that's 10. 10 plus 2, 10, 11, 12. So then what do I need to add to 12 to make 21? That is 9. So I put 9 up. This one can carry 18. So now it's just like you have a vehicle that can carry 18 passengers. But 10 seats are bad. But for this scandium to zinc, they now start repairing the 10 seat. They manage to repair 1 of the 10 seat here. So that this one can carry additional 1 to the 8 that this one and this one is carrying. So then when they get to, as you move progressively, they will be repairing 1, repairing 1, repairing 1. So number 22, you have titanium. Titanium Ti. So this one will not be 2 to 8. This one will not be to 10 to 2. So they manage to repair another 1 so that at least you can still carry 10. So then the next one is 23. You have vanadium. Vanadium V. Vanadium V. This one will not be 2 to 8 to 11, then to 2. All of them are ending in 2, 2. The increment is always at what? M share. 9, 10, 11. Then 24, I will start it. Itself and 29. That's chromium. Chromium Cr. Now, this is 24. Look at this. Copper and chromium. They are the only one that will come and have 1 here at the outermost. So you have 2 to 8. It's supposed to be to 12, then to 2. If it will continue like this. But no, copper and chromium, they will end up filling the outermost shell with what? With 1. And that one that's supposed to say will not be added to this. So that you will not have any member with 12 electrons at M shell. So that is that. Now, we move on to 26 now. 26. Now 25. We have manganese. Manganese Mn. Now, the manganese have 25. That's 2 to 8. He is the one that's supposed to have to 13. I think this one is 12 to 13. But it is different from here now is that it will end in 2, while this one ended in 1. So you have it there. Then the next one, number 26, iron Fe. So that's 2 to 8, then to 14, then end in 2. The next one is 27, cobalt Co. So this is 2 to 8 to 15, then to 2. The next one is 28, nickel Ni. Nickel Ni will now be 2 to 8 to what? Then to what? Nickel to 16, then to 2. So 29, now let me start it again. Then this one is copper, behaving like chromium, Cu. Now, you have 2, you're supposed to have to 2 to 8 to 17. You're supposed to have to, this one you're supposed to have. But silver and chromium end in 1 and double fill this place so that there will be no 17 equivalents. Then number 30, that is zinc. Zinc, Zn. Zinc has 30 electrons, that's 2 to 8. Is the one that we are supposed to have the 18. This one is 16, this one is 17, this one is 18. Then but it ends in 2, not 1 like this one. So now the next thing we are going to look at now is atomic orbital. So stay tuned to my YouTube channel titled Afe Ademola Johnson. Please go there, download watch, get a lot of videos you need in your education. So now we are stopping this class here. See you in atomic orbitals. And please share this video, like it, and subscribe to my YouTube channel. God bless you. I remain my humble self, Ademola Johnson. Thank you and bye for now. Please, if there's any question, put it in the comment section. Let's discuss. God bless you. Thank you.